Hello, a very good afternoon to all of you. I am Pallav, and it's my pleasure to welcome you all on behalf of eMobility Plus and First View Group. Our today's webinar, which is on decrypting EV battery value chain, defining strategies to improve quality and productivity, brought all of us together on this common virtual platform to gain insights from our experts that how batteries are emerging as a critical ingredient in the transition to a more sustainable future because of their role in electrifying transportations and balancing power grids. Hope you had a great time networking so far with your peers, but if you have missed out, need not to worry. This will continue again after the webinar till 5 p.m. So now let me quickly brief you about today's program. We will start the webinar with a very interesting presentations. Then we will have our panel discussion followed by a Q&A. But before starting today's program, I must thank Vyas 3D for their immense support in planning and executing this webinar. So can we have a virtual round of applause for our event partner? Great. So without any delay, it's time to start the program with the presentations. And for this, we have Mr. Bhavesh Kumar, who is the Managing Director, Vyas 3D India. Welcome on screen, sir.
Thank you, Pallav. Really great to be here.
It's all our pleasure, sir. Please.
Okay, just to introduce myself, my name is Bhavesh Kumar. I am the Managing Director for YS3D, and before that, I was a part of the simulation brand Simulia of Dassault Systems for about 18 years. So what I would like to do is, start with a very brief presentation about YS3D and also set the stage for the panel discussion. So let me just share. Okay. So I hope all of you are able to see the screen. So YS3D is as excited to be a part of this panel discussion on decrypting the EV battery value chain. Before we get into the discussion, I'll keep this really short so that we get to the crux of the event fast. YS3D is a partner to Dassault Systems, a platinum partner in North America and a gold partner in India. YS3D's focus is broadly on the scientific simulation domain, and we are one of the largest simulation partners in India for Dassault Systems. Besides simulation, we also look at engineering design, digital manufacturing, as well as some aspects of data and business analytics. So all these disciplines, we typically consider them as separate disciplines. We all know that they are intricately connected to each other and they are dependent on each other. We all know that, but somehow we kind of get lost in the hustle and bustle of getting our product out into the market. And the way to tame this complexity, this kind of interdependency that you have, is typically to use a systems engineering approach. This is nothing new to rocket science and the aerospace and defense community, which has been using systems engineering approach for quite some time. But this is certainly a growing trend that we see for electric vehicles. And at the foundation of all this is a platform that supports digital continuity, linking all the business processes, all the business functions. And this is what we aim to do as YS3D in our partnership with Dassault Systems. As a part of the partner ecosystem of Dassault Systems, we tend to focus on emerging industry trends. Whether it is electric and autonomous vehicles, high-tech areas such as 5G networks, as well as healthcare. And one would be surprised, how much of cross-pollination happens between different industries, and technologies that are used in one industry find their way into some other industry in a different way. And it's always exciting to look at how things are used across different industries. So with that very brief overview, I want to kind of set the stage for our panel discussion. We talked about interdependencies, and electric vehicles are no different from batteries and motors, dynamics and safety. there is a whole lot of engineering that is connected, and this is truly a multi-scale, multi-domain, multidisciplinary problem. And I would say that we have found ways to get around this. One way of taming the complexity is to break it down into smaller components that can be easily managed, and we are going to talk some of that during our panel discussion as well. So that is where the whole systems approach comes into the picture. And if we look at batteries, we are fundamentally starting from material modeling and electrochemistry, and then moving on to aging, charging and discharging cycles, thermal characteristics, and so on. And from there we go to the levels of battery modules, battery packs, BMS, and then it goes into the vehicle, where we are talking about vehicle integration as well as integration physics. And what I am going to do is to use this as the basis of our panel discussion as well. And just to round it off, we are talking about batteries, and while electric drives are not the focus of today's discussion in general, I wanted to highlight this just to show you the diversity of technologies that is required to characterize their performance, from durability and reliability and safety, to aspects of electronics, structures, fluids, thermal management, and so on. So that's a very brief overview that I wanted to share, and I would now like to start with our panel discussion. So let me first stop sharing the screen. And I would like to invite our esteemed panelists, and I would request them to introduce themselves. Uh, Mr. Pankaj Sharma from Log9.
Hi everyone, this is Pankaj. I'm one of the co-founders at Log9 Materials. At Log9, we are focused at creating cell to pack to the entire battery level technologies, focused towards creating business to business solutions when it comes to electric vehicles. Um, and our technology is primarily designed to ensure that our business partners, whether they're driving two wheelers or three wheelers, get the best EV battery technology so that they can insta charge those vehicles within 15, 30 minutes rather than hours. And create a technology and a chemistry that is extremely safe so they can go about their business without having to worry about the safety of the batteries, and give them a solution that doesn't degrade that fast. So, batteries that can last 10 years is what we have been always focused about.
Thank you, Mr. Pankaj. Mr. Harshad.
Hi all, this is Harshad, founder of EMobility. So we are based out of Pune, and we are launching our first electric cargo vehicle in this year. So I myself has worked extensively with EV powertrains and battery technology for 4 5 years before starting my own startup. And safety is the most critical issue. Most of the customers are worried about performance and safety, and this is where we are putting in a value. Thank you.
Thank you, Mr. Harshad. Dr. Yashodan.
So Dr. Yashodan will be joining. He's there. I
Okay.
mean, we're trying to figure it out, and he will be joining in 1 minute. Next 1 minute, I will inform.
Okay, sure. Okay, so we can start our discussion. Okay, so I had just talked about how it all starts with materials research and battery chemistry. So therefore, I would like to start with a question to Mr. Pankaj Sharma of Log9 Materials. So Mr. Pankaj, as you also said, Log9 has been working on advanced technologies to develop rapid charging battery packs. And the need for such a fundamental research is always felt, not just in terms of looking at sustainable alternatives, but also in terms of the global supply chain risks. Um, so my question would be, what kind of challenges do you see from the perspective of supply chain and sustainability for batteries, and the critical gaps that you see for India to become self-sufficient in this kind of a domain?
Yeah, I think it's, I mean, even if you look at the kind of number that have been coming through, in 2015, the total installed battery capacity was about 16 gigawatt hour. By 2020, we had already reached 450 gigawatt hour. By 2030, we're expected to touch 2 terawatt hour of installed battery capacity. What it means, it kind of gives you a roadmap that we're adding almost 30 to 40 gigawatt hour of battery manufacturing globally. And so when you have that kind of capacity being installed globally, it puts a very severe stress onto the supply chain of those raw materials, because it's not a steady state manufacturing sector. It's a hyper growth stage manufacturing sector. And so the typical challenges which is there is, so India has been late to the party like everybody else. China has been the advanced mover, so they went ahead and were able to secure a lot of supply of the raw materials, which we don't. Neither at a country level, neither at a company level, we've never gone into that. So the first challenge that a company like us, which is completely into cell technology, is that we have to compete against companies and organizations that have been doing this for almost 10 years now. And these are typically Chinese companies. So they already have the supply chain secured with them. And hence you have to sort your own raw materials. The other big challenge that we see is that most of the supplies, whether it's nickel, cobalt, lithium, what we kind of decided is that there are certain things that we can, by design of a smart cell, we can eliminate certain dependency in supply chain. For example, we were very clear when we were designing our cell chemistry that we wanted to limit our exposure to cobalt. Cobalt comes from BRC. You have the Bolivian, Argentina, and South America, that particular triangle where cobalt is available. Uh, sorry, cobalt is mainly in BRC in Congo area, and it's a very the supply of that raw material is very tricky. So we had an opportunity to kind of, because we are starting cell chemistry from grounds up, so we design a chemistry to stay away from cobalt. And similarly, uh, the other thing that we also saw is that the lithium and the nickel that is needed, uh, even though lithium is fairly largely present available, but the final step, whether it's coming from the brine ponds or ultimately the final formulation, final purification, lithium carbonate or lithium hydroxide actually happens in China. So you have to go back to China to buy your lithium. So even if you get raw material, you don't get the final formula that you need. So a lot of dependency on that. But what I wanted to kind of talk about today is there is other materials, simple materials like metals like aluminum or copper that go into battery. We don't even get that in India. So even for those simple metals, India is the second largest manufacturer of aluminum, but you don't get a single square inch of battery grade aluminum in India. So you have to import everything. So right now, the challenge for a company like us is because our entire raw material is dependent on import, which severely restricts your ability to now produce cells which can compete at the cost structure that probably a Chinese company can do it. So it will always be expensive to produce cells in India, given that we don't have the raw supply, and our supply chain is dependent on export. But we've taken a call and we've started with it. So let's see how we in future we will optimize it. But right now, huge dependency is on imports.
Sure. Um, so, Mr. Pankaj, maybe as a follow-up question to what you had said about the dependencies that we have on China and other supply chain risks. One of the points you made is also in terms of when you talked about the dependency on cobalt, that you were looking at materials that would not make use of that, which would basically mean you would have to literally do some kind of a material discovery kind of a process, right? And I see that you've also been looking at nanotechnology and drug discovery on the other side of it. And that's the cross pollination. If you could maybe shed some light on that, because these are like two different industries, but it appears that you're kind of getting them together to address some common issue here.
Absolutely. See, whether it's drug discovery or cell chemistry, at the end of the day, you're working with materials. And a lot of people don't realize, but lithium ion cell chemistries are very dependent on sorry, your understanding of nanomaterials. So while I was building my drug discovery companies, I was building nanomaterials, nanomedicines, polymeric nanoparticles. I was trying to put drug molecules into that. But at Log9, it's this similar approach, because what's happening is you on a particular, for example, when you're building your one of the whether it's a cathode or an anode, you need to coat certain things, and when you're coating certain things, you want to coat them at a certain particle size, and you tend to get into nano meter range. Sometimes you get a micron meter range, but it's the ability to work with materials at that small level, and to be able to understand the chemistry, the binding properties, the intercalation of those materials, and how they stick to a particular metal, and how do you stabilize that so that you are able to collect the current without degrading the layers of materials. So building lithium ion cells at the fundamental level is literally a chemist and a material science guy's work. And that's what we realized, that to kind of create the lithium ion technologies, we had to get into basic fundamental science. And that's why guys like me in Log9 are able to contribute, who understand things science at a fundamental level, and then bring a product that uses that fundamental understanding of particles, molecules, binders, polymers, metals.
Sure. Thank you, Mr. Pankaj. And, that was the battery chemistry part, and I would like to move the discussion to battery packs and modules. I see Dr. Yashodhan has just joined.
Yeah,
If you could, hello,
yeah,
good afternoon, Dr. Yashodhan.
yeah.
Uh,
Thank you.
if you could
Thanks.
just introduce yourself
Yeah.
to the audience.
Okay. Thanks for organizing such a wonderful event, and thanks, Pavesh. Sorry for delay for technicalities. Myself, Yashodhan. We make the lithium-ion battery packs and BMS. We work on the commercial vehicles. We have introduced first time in India liquid cooled NMC battery packs, which have been running few millions of kilometers in Indian conditions. So there are, yes, challenges. The someone is driving the electric vehicle in Tokyo, New York, uh, Berlin, and somebody is driving the vehicles in the Guwahati, Rajasthan, Chennai, and Nagpur and Mumbai, where the temperature plays a various roles. And we make in-house the battery packs. BMS is completely indigenized, and we are going towards the making the all the parts localized. And as Pankaj has rightly said, in coming future we will get the cells which are made in India, which can compete with our neighboring country. So that's we are looking forward. Yeah.
Yeah, thank you, Dr. Yashodhan. So, uh, we were just discussing the battery chemistry part with Mr. Pankaj. So, I wanted to ask you about, you mentioned about the BMS as well as the validation of the performance of the battery packs. And Octillion has been supplying battery systems for cars and buses and trucks, and there is a lot of validation that would be required. So I would say I have two questions. One is to take the theme of our previous discussion in terms of the lithium-ion supply chain itself. In terms of how it is impacting the overall ambition towards EV adoption in India. And two is from the perspective of validation, because there is an on-road validation that would be required as well. Like you rightly said, there is a car in Tokyo, in Pune, in Chennai, and they all have different conditions, and it is necessary to really take that into account. So, what, in your opinion, are technologies that need to be considered to ensure that there is a thorough validation that happens for battery packs?
One of the important thing I see, whatever you are seeing the news with the fire and all that thing, it's a part of the transition, because at some point you just can't select the cell which is just cheap quality, so your battery pack is affordable. No, the reason is it's a safety, reliability, and longevity is more important. So when you select any cell, may Pankaj will give more insight. Like, there is a lot of criteria even the cell making, but cell selection in terms of the safety, durability, because it's a high energy product and you have to treat it carefully with our condition. And India, the country where the temperature goes from 0 to 45 degrees same day, and you can't tell your customer don't drive in extreme summer. So these are the challenges that you have to do. And in terms of the validation, ARAI, ICAT are instrumental. They are doing the good work, and they're also in the evolution phase, like in terms of the DVP. At the moment, for the high voltage battery packs, say more than 100 kilowatt hour, 720 volt, these Indian institute, which are the certifying bodies, they are also developing their testing centers so that we can test this validation. Earlier, it was dependency on our neighboring country to do all design validation protocol for from drop test to fire test to thermal test. But now we are in that process to do that here in India.
Okay. So you're saying that the kind of rules and regulations that we have for traditional vehicles are slowly being applied to the electric vehicles as well, and institutes like ARAI or
I can,
they're working towards these kind
yeah,
of norms.
yeah.
Okay, okay, okay.
Okay, one of the example is AI 048. Earlier, there is a standard. It can be changed by AI 038, where thermal propagation is very well taken care in the new standard.
Okay, okay, okay. Uh, So I'll come back to you, Dr. Yashodan,
Yeah.
on a few more areas. I want to move to Mr. Harshad. Really looking at moving from battery packs to where they finally go into, which is the vehicles, the vehicle integration part. So, Mr. Harshad, e-vehicle mobility is aiming towards an electric vehicle platform. That can work for both urban and rural scenarios. I understand that that is what you and your team are working towards, and that you are currently in the prototyping phase. And I'm sure that this is also going to involve a considerable use of technology, advanced technology, whether it's engineering simulation and systems approach and so on, right from assessing the safety and durability of the vehicles, as well as ensuring that there is an exciting experience for the driver and the passengers as well. So could you throw some light on the use of such advanced technology that you use and that you would recommend for anybody who is looking into the EV development process?
Yeah, I mean, so it's a very good flow. Like Pankaj started from cell, what kind of innovation they are doing, what are the problems. Then Google sir also threw some light, what kind of tests they are doing. So when it comes to the vehicle, so like nowadays, this simulation and modeling has become a very good practice. Most of the startups, most of the new companies, and the big players, they are using these techniques, and we also have extensively used it. So currently, we are also in a certification phase, and the seeds that we sowed 1 year back in terms of doing the model-based simulations for our vehicle. So yes, the battery pack maker takes the extreme care when they are designing the battery packs. But when it comes to the vehicle level, we also need to see how vehicle responds to the algorithm set in a set in a BMS. So in when I was there designing my powertrain, so we developed our vehicle control unit completely in house, and there we extensively use the system based modeling. So we put additional one layer of safety on top of what BMS or battery packs could offer. So right from doing the thermal modeling of battery packs and how the temperature could increase in different profiles and how to reduce the torque requirement or overall current requirement from the motor controller side. This is also one area where we use this model based simulation in a very deeper way. So I think this is in general, whoever is working on developing such vehicle platforms, it's very important to use the simulation, test it on road. Not just simulation is not, of course, sufficient. Test it on a first lab test, and then test it actually on road is very important thing.
Okay, okay. So could you share a little more about the testing and the prototyping and the simulation? How do you kind of bring all of these three together? Because these are very iterative processes,
Correct.
especially at the vehicle level, because moving from batteries to packs to vehicle. With vehicle, you have a lot more uncertainties and dependencies that you're looking at. And then as you rightly said, simulation itself may not be sufficient. You're looking at the tests as well as the prototypes as well. So if you could throw some light on, how do you manage that test prototype simulation kind of a process?
So to start with very basic model of vehicle, we started off like what could be the range that we are targeting. Then for that, what will be the battery and motor requirements? That's now pretty much common. The material is already available. So after that, we started going into more details of each and every component. So we design a modular simulation platform where so, for example, manufacturer X, we are taking a batteries from them. So then we are on a battery pack level. We did a modeling of that battery pack and put it in our simulation. From the motor controller motors, we were getting from manufacturer Y. So again, we dig deeper into their models, how they behave at different conditions, and we put in our simulation platform. So many times at the time of design it happened that okay, we decided to go ahead with certain component, but after some time due to supply chain issues or due to the technicalities we had to change. So since it was a modular based design, we could easily adapt. And I just mentioned that we designed our own vehicle control unit in house. So the good point was the vehicle control unit is it is designed in a such a way, its software is designed in a such a way that directly the model based simulations or the model that we have created, that could be directly coded into VCU. So we don't need to go to the very embedded C level coding to change if there is a certain change in another component of the vehicle. So this is how we did the modeling. And when it came to testing, so I understand, like I also worked for 4 5 years in same industry before, and not everything works perfectly well as we have done a simulation. So we actually built a test mock-up electrical powertrain, like everything we put together apart from a mechanical structure. We run our algorithms on that powertrain using dynos and other hardware in loop type of machines. And then we tested how it reacts to different temperature, how it reacts to different road conditions. And now we have come to the stage that the proto is ready, and now we are taking the test on road whether what we have done so far is working in real life or not. It has saved a lot of time for us. Otherwise it would have been a very iterative process, do certain changes to the changing algorithm. So this has saved a lot of time for us, and we are sure that in ARI certification also, of course they don't go up to this deeper level, but yeah, there shouldn't be issue.
Sure. Thank you. Very interesting. I would like to come back to you on the modularity part, that you mentioned. But before that, maybe coming back to Mr. Pankaj, one of the areas that I wanted to maybe check with you is on the charging infrastructure side, because you are also looking at rapid charging technologies, especially for intracity two-wheeler and three-wheeler segment. Uh, so what are your views on the charging infrastructure? Because at least in the past, this was always considered as one of the bottlenecks for rapid EV adoption. Is that something that you see changing? And any comments on how government initiatives are kind of helping with some of these challenges?
Yeah, I think it's improving for sure. When we started 2 years back, the charging infrastructure density was less. It has improved substantially, and we're continuing to push for installation of more and more charging points. At Log9, we're working with all 10 major charge point operators. The model that we have entered with them is that so it's always a chicken and egg. That's what they talk about. Should I put a charger, and what's going to be the utilization for that? So the way we realized to solve that is that you directly engage with the charge point operators and give them a demand forecast. You give them a captured demand, so that because when we're working with our fleets, we have, let's say, one particular company that may be running 200 of our vehicles. We do a route mapping with them, and we say, okay, fine, for us to enable these 200 vehicles in a particular city, what's the typical density of that route map that they do? Our batteries come IoT enabled, so we're able to track see user behavior, and really figure out as to what are the key points where if you enable the charging points, then this entire 200 vehicle operations become frictionless. And from that point onwards, we are able to enter into a conversation with the charge point operators, and then we engage uh, to ensure that there is enough charging point density comes up. Second thing we've also done is we've created something called we call it the power bank, which is actually a mobile charger. And that really helps us before we operators to install charging infra. What we do is we take our mobile charging unit and place them in strategic locations, and then check how that particular charging box improves the overall uptime of the vehicle. So what the customer is asking for is not range, especially in B2B sector. What they are asking for is high uptime. And the only way you can give them high uptime is if you can give them an opportunity in their normal day-to-day operations to have opportunity to stop for 10 minutes, charge and go. And because our batteries are designed to take that high current in, so we can charge them in, let's say, 10-20 minutes is the idle time. So by creating, you don't have to really densify the charging infra, but you have to strategically place the right charging infra at the right place. Enable an ecosystem. Is it perfect? It's far from perfect. We need to do a lot more, and I think government definitely has a role to play there. For sub 100-volt systems, we are working with Bharat DC 001 GBT chargers. So I think the protocol that we use is something that's already designed to give high energy into sub 100-volt system, and the government of India has already invested into that network. Before Log9 came, the utilization of those chargers were about 7 to 8%. After we came and our demand supply went onto those chargers, we are now able to push utilization of some of the charging points as high as 70 to 80%. That's generating revenue for the charge point operators, that's generating revenue and utilization for the government when they installed all of that. So I think the way to solve charging problem is not to point the finger onto charging network issue, but to really create a technology that uses the charging infra very fast, and then work very closely with your customers to ensure that they're able to go and use the charging infra in a very swift and effective manner. Once you start to do that, then the chicken and egg becomes a supportive equation rather than diametrically opposite problem that are trying to grow separate from each other.
Okay, very interesting. And uh, so what I would like to do, Mr. Pankaj, you talked about the charging infrastructure part, and how the government plays a role, and maybe to Dr. Yashodhan, a similar question on the lines of how it is impacting the integrated supply chain itself. We typically look at government initiatives in terms of the output, which is more in terms of the subsidies that are offered and things like that. But maybe your comments on how that helps in the supply chain side itself.
Yeah, good, Bhavesh, you have asked. Like, one of the key thing is government is surely putting a lot of duty structure. If you are importing the complete battery pack, at the moment, what people are doing, order the battery pack from neighboring countries, put the sticker, and use like this is their own product, and they are doing for many years, where they can use the low quality contactors, then chargers especially. Then there is no BMS sometime because all is the cost driven. That impacted. We have seen the last few months a lot of fire incidences in two-wheeler, three-wheeler, or whatever the segment. To avoid that, government is doing the other structure with increasing the import duty 15%, 20 or more. That can promote local battery pack manufacturers in India. And supply chain is like a chicken and egg. Earlier, for example, to give you an example, to connect the modules, connect the cells, you use flexible bus bars. Flexible bus bar is not a rocket science. It's like sandwiching copper and doing the silver at the end. But nobody was doing at high voltage. I'm talking about 720 volts. Even wiring harness, good quality wiring harness for the high voltage system is not available. But as the demand increases, there are many players who are coming up which can help. And one of another parameter is the cold plates liquid cooling system, because there is no demand. Still we have a dependency on neighboring country for that, regarding the precise good quality, because when you go with a high voltage system you need a liquid cooling. There is a cost, but that is compensated, amortized over the period, because the temperature is a killer, and we are fortunate or unfortunate, we are in that domain, the country like India. So we also have a target end of the year as Optilion to have a complete localization. We are working towards that for last 2 years, and focusing on the domain and then diversifying in other verticals. And we done that in terms of the data logger. BMS is completely make in India. Obviously chips we have a dependency, but rest of the things, and which are certified with the testing agencies. In terms of the DVP, there are 50 tests just for BMS other than AIS standards. Then for a huge battery pack there are more than 20 tests, including drop tests, salt spray. There are various things, but that intensive validation is required before putting your battery pack on the road. May alpha beta, there are various proto samples, but when it goes to a customer, because it's a hazmat product, high energy product, so you have to treat that with respect in terms of the safety norms are checked.
Thank you, Dr. Yashodhan. So, if I may just ask one follow-up question based on what you said, you talked about how certain government regulations, have started creating some demands, and then the local manufacturing picks up based on that. Especially in the context of the EV, would you like to throw some light on the manufacturing aspects? How you see the manufacturing itself. We typically talk about the end product, but the manufacturing process itself, what kind of challenges and issues that you see there?
Manufacturing challenges, one of the main challenges getting the cells in India. That's a major challenge. The cell price increase after the war more than 40%, because there are different parameters. Pankaj knows that, including from lithium, electrolyte, or many other things. So that is the major challenge. And for every cell, you need a separate BIS certification. You change the cell, you change the certification. It takes the time. And other like the chip is the, I don't want to talk on that. It's very well known. So you have to work with the different suppliers in terms of the chip shortage and all that thing, and then good quality wiring harness, contactors, whether it is. And but one important thing I must say, the company, my software companies that will help you in parallelly, like ANSYS, Fluent, especially in the thermal is concerned, you have to do experimental on this. When you select any cell, you have to do nail penetration, thermal propagation test in-house or whatever the testing agency. But parallelly you have to generate the simulation conditions where you can add the humidity parameters, solving Navier-Stokes equation, which can help to get near to the reality. And supply chain, yes, there are still some challenges in terms of the cooling part is concerned and quality checks basically. But that due diligence, PPAP, and everything has to be done parallelly. Basically.
Thank you, Dr. Yashodhan. I would like to move to Mr. Harshad to continue the discussion on the modularity part. As since we talked about the manufacturing aspects, it was very interesting to see the approach where you're looking at multiple scenarios for your three-wheeler and four-wheeler vehicle programs. You talk about having the same platform that can be used for multiple scenarios like tippers and delivery vans and things like that. So I presume that you would have used some kind of a modular approach to the program. It would be very interesting to hear your thoughts about how you go about the whole modularity part for your electric vehicles.
Yeah. So before answering this question, I just want to add one more thing, that the previous discussion that Yashodhan and Pankaj was saying, like the getting the raw material, or the getting the, for Pankaj the raw material is the electrolyte, cathode material, anode material. But Yashodhan, it's a sale. For us, the battery and other component. So fortunately, uh, so the other components apart from the battery. So fortunately, sir, India has a very good ecosystem already in place for automotives. So I would say, at least for a below 100-volt category, it's very interesting to see many Indian players are coming. They already have a product. So rather, I would say my vehicle is, yeah, designed in Pune and also manufactured in Pune. Almost everything is coming from Pune, apart from, of course, the battery cells and a battery pack. So that's one good thing I saw here. Other head hack of getting the sales, and other getting head hack for getting the electrolyte and all that, Vishodhan and Pankaj, people like them are taking care. I'm thankful to them. Uh, so coming back to the modeling and introducing modularity into that. So of course, for three-wheeler and four-wheeler, the architecture is different. The voltages that we are, the powertrain that we are using is different. So four-wheeler is higher voltage, up to 90 voltage we are working on. But we are completely focusing right now on three-wheeler. And when we introduce the modularity, so what is the common in between any critical component of the vehicle? So one, it takes the power for electrical powertrain, I'm saying, and another, it has some kind of communication. So we have modularized this two parts when we design, any basic simulation or any basic model. So if tomorrow there is a different protocol or different algorithms inside a one particular component, say BMS has a different CAN matrix, or the more MCU is programmed to send certain data, and it can receive certain parameters, so that the performance will change. So the only parameters is the one thing that we have to change. So in short, whenever we go for any simulation, creating a simulation model, it has to be completely parametric, so that adapting to the new demands, or taking the same platform to the new design will not be a big issue. And as I said, uh, most majority of the part goes into the validation of the embedded code, and if there is any bug remaining or that. So now the simulation platforms have become so much robust, that these things has not to be done. Only thing is, our hardware has to be compatible, be able to work with those particular simulation platforms.
Sure. Uh, Mr. Harshad, you make parametric simulation seem so easy, but I'm assuming that there is a lot of hard work that goes
Yeah,
behind the
there is a
scenes.
lot of hard work. We have to,
Yes.
yeah, we have put a lot of time, at least 5 to 6 months. We have put on doing the proper simulations, and
Yes.
then come up with the final models.
Okay. Sure. So I'll just shift gears a little bit to the last leg of our panel discussion. And Mr. Pankaj, I wanted to ask you on, I would say, more from the perspective of advanced simulation. You had talked about it at the start as well, but I was also wondering if you look at certain data analytics part, because I'm sure that with the kind of research that you do, and the data that you gather from all the performance scenarios that you look at, you have like tons of data. Do you consider right now getting into some of the data analytics, or maybe sometime in the future, to make use of the data to perhaps take certain decisions in terms of research and R&D?
Yeah, absolutely. I think for us, data is at so many levels. Uh, at the cell design phase, there is a lot of. So we do our own simulation work to understand how. Uh, so what you're doing is, when you're creating cells, you're creating certain surfaces, and you want surface to surface interaction, and the way the entire material comes together. What you want to do is, you want to really characterize your materials that are going to go into the coating part of it. So there is a certain micron size, for example, that we need on some of our cathode materials. So we create those simulated walls to see whether that kind of macro structure will allow lithiation and delithiation processes much more better. Because sometimes you over optimize. I'll give you a simple example. If you use a smaller particle size on your cathode, what you start to get is aggregation of material onto the cathode. So you have a lumpy, irregular surface. If you make your particles larger, you get a drop in voltage, but you get a more even coating. But that also doesn't something you don't want. So there's a specific trade-off between particle size, the smoothness of the coating, and the channels that it creates for lithiation and delithiation to happen. So it is a fundamentally at a science level, we do a lot of simulation work internally to map out the right molecular structure that we need, or the right macromolecule structure that we need before we coat things up. So that's one level of data crunching that we do to select the materials, particle size, dynamic light scattering, zeta potential. All of that is needed at a particle state level. When the cell starts, so when we start to coat the cells, when this, the coating is starting going on, there's a lot of inline QC that we do to ensure that the cathodes are being coated, and you have non-destructive ways of, while you're producing the cathodes, you can actually see how well the process is working. You don't want batch to batch variability. So whether it is bouncing a laser back from that to capture data points onto a particular cathode, or using an X-ray to look inside the cell without destroying it to know that how that particular thing is coming up. Another part is, because our cells, we are perhaps the only one here in India that has created the tabless technology. So when you create a cell that is tabless, you get a much better thermal conductivity through it. And to simulate that thermal conductivity, again, we simulate that and then cross check it. There's always, once the cell is ready, we cycle them, we try and push more current, and then see what's happening to the cell, how the heat characteristics can come up. So a lot of data gathering starts to happen. A lot of stuff that maybe I'm pretty sure that Yashodhan does a lot, which is cell sorting and bring the right kind of cells together to work in a particular battery pack. So that's the kind of data they would be using at Octillion. We're using similarly. Ideally, what you want is minimum cell to cell variability. And what parameters do you set in your charge cycles decides how good and accurate you can sort your cells. I think we are down to like almost in 0.2, 0.3 cell to cell variability. So I think data gets accumulated in an organization like Log9 at multiple levels. How we use it, some of it is fundamental science data, some of it is very meaningful cell sorting data, some of it is very fundamental vehicle run data on the road when we're running it, and we're trying to see what has been the charge discharge cycles, what has been the what has been the thermal characteristic of the battery when it was there in the vehicle use. So I think we ourselves recognize that what we're doing is on a daily basis generating tons of data, and then a lot of it's getting internally characterized. Uh, and it just makes you more smarter to go out and bring out a better system on a quarter to quarter basis, because you can, once you have mapping your data, where you can improve on your system so that you can give a better system out tomorrow, and you can do some preemptive analysis and diagnostics onto area of development in the design piece of it.
Thank you, Mr.
Bhavesh, just to add on Pankaj, he has rightly mentioned like particle size plays a very important role in terms of the lithiation or delithiation, and the second is the rheology, because you are mixing the binder, solvent, the anode and cathode material, and that the fluidity of the liquid, fluidity of the polymer, plays a very important role when you are coating, because that thickness, then the even particle distribution on the aluminum or the copper foil where you are cutting. Because just imagine you have a A4 sheet, you have coated your paste. After drying, you cut at the initial front corner and at the end of the sheet, if and make the cell basically and test it. If ideally both the cells supposed to give a same cycle life, but if the rheology and the particle size distribution is not proper, one cell which is cut from the upfront will give you only 500 cycles, or vice versa. So that plays a very important role, rheology.
In fact, Dr. Yashodan, my next question was to you also, because I know that Octillion gets into a lot of data gathering, and I see that you talk about billions of miles clocked with the battery systems. So could you also share a little more about the kind of data analytics that maybe you foresee in the future, and how it
Yeah,
would help in your BMS and other decisions?
like one of the thing is getting data is one thing. Like for that, we develop the data logger because that's a requirement from the cell supplier. You get X-year warranty in different countries, different continent from the cell supplier because of the road condition, temperature, and these conditions are ideal for the cell. But the country like India, where the temperature big difference, so cell supplier is worried to give the warranty. They can't give the same warranty, and that's the main bottleneck for any EV domain. The warranty from the cell supplier, and how to determine that, that's a different discussion. But the data logger that we have developed in house and put it in more than 500 600 bus vehicles, that will help. At the moment we are retrieving this data just for in case of any problem or anything happen, but these data loggers, this data will help in future. One of the thing is where to put, as Log9 is already working with chargers and all that. If I'm going, say, from, say, for example, Pune to Mumbai or Pune to Bangalore, these data points will help at which place I have to put the charger. Still, we talk about the big data, but how to commercialize it is a different view. But that will help. Second is the degradation. If I'm using my battery in bus or car, every day I'm driving, say, 50 kilometer, the weather like Pune or weather like Nagpur, the degradation is totally different. And after, say, 4 or 5 years or whatever the warranty given by the cell supplier, what to do with that battery? People talk a lot with second life and recycling, but there is no right answer here. It's a Nobel laureate question, like how to do the exact SOC calculation. How I recognize my exact SOC, exact wear and tear of the battery pack after running in Indian road conditions with 50 degrees C or in winter 0 degrees C. So it's in the evolution phase. So hopefully in few years time we get that answer regarding the data is concerned. And third is like recycling, that will also eventually come.
Thank you, Dr. Yashodan. So, uh, with that, I'll come to a conclusion of the panel discussion. But before I do that, I would request you to share any closing thoughts you have with the audience. With Mr. Harshad, if you would like to share a few words.
And I think it was a very great discussion. Like right from cell to EV, we covered almost every aspect of what's happening. And yeah, Yashodan also correctly mentioned. Even now, at this moment, after so many years of lithium-ion battery has already been commercialized, a simple thing as calculating the accurate SOC is still a big question. If someone comes with a very magic wand, I will be like everyone will be very happy. And yeah, it is evolving field. Fortunately, India, there is a huge push towards electric mobility, and I am confident, not just as a entrepreneur who is working with EVs, but in general, like compared to any other part of the world, the EV adaptation will be much more faster and much more higher. It could be in terms of two-wheeler and three-wheeler or even a public transport. But yeah, in upcoming 5 years, the adaptation is going to be very higher, and all of us working in a different domains of EV has to work really very hard to reach up to that stage.
Thank you. Thank
So before going to any any more closing remark from two of our distinguished panelists, we have some questions from our audience still there in the Q&A box. If you like, you can have those questions. We can answer them. Otherwise, I can project you one by one on the screen. how you like to take about,
I
sir?
can, I
Yeah.
can Pallab, you can project it so that anyone can answer. Yeah.
I
The
think
I think I have already given this question answered. Like quality, you have to follow the standard certification processes, validation. It's not only the criteria, it's kitne mein diya or kitna degi, like cheap, cheap, cheap. So you have to follow that protocol, the proto cycle, validation, and then SOP. Then only you can have a safe, sustainable product.
Yeah. I'll add further to that, I understand the background of this question. Maybe like as there are so many companies who are now going into jumping into two-wheeler particularly, and they all have this question like how to judge whether it is a good battery, because two-wheeler, if you are not going for high configuration like Ather or Rolla, so it's a very cost comparative. So generally people say, as just Yasujan mentioned, ki, कितने में मिलेगा वो, what will be the cost of package. Instead of that, you also need to think about the future cost. What if you have to recall your vehicle because of bad bad battery pack or bad cells? So that's a very huge expenditure. And as an OEM, we also need to set up some kind of battery testing at our own. Okay, we are taking a very reputed company, reputed brands like Octillion and all. So still we have to do our own testing. We have to uh, connect it with our battery, with our vehicle powertrain, and do the testing all again, even if there is a data from BMS or battery manufacturer. That's the only way.
Actually, there is no right and wrong answer in that. Whole Europe use NMC. We use NMC in all our programs in last 4 years. No issue because we use NMC liquid cooled system. But going forward, in terms of the fast charging, safety, and cost, cycle life, people are shifting towards LFP. LFP has their pros and cons. So every chemistry has their pros and cons. You have to choose your applications and your strategy towards future. May you want kitne mein diya kitna degi, or you want safety sustainable product, that you have to answer. I think Pankaj will add more.
I think it's becoming very, very clear that a lot of people, a lot of time this question comes up, and NMC chemistry in Yashodhan's hand is a very safe chemistry. The same chemistry in somebody who doesn't understand liquid cooling, that chemistry is a very dangerous chemistry. So rather than using common denominator chemistries as a common denominator, that whether NMC is better or LFP is better, it really depends who created that battery pack. What are the secondary systems that you build around that battery pack? And second is, what is the use case, like what Yashodhan and Harshad talked about it? What is the use case for that particular battery? If the intention is to have a battery that gives you longer life, you're starting to lean towards, but let's say slightly lower energy. You're looking at something that you tend to move to more towards LFP, where you do, and you have systems like a two-wheeler where putting cooling technologies is tough. So you look at the use case, you look at the company that's making, for example, a lot of conversations has happened around Ather. Ather uses NMC, and Ather scooters have been extremely safe. Whereas there's another OEM whose NMC scooters are catching fire. So there is this caution that maybe the chemistry is wrong. It's not the chemistry is wrong. It's the engineering talent that brings that chemistry as a solution to the market, that decides what the chemistry can perform. Tesla worked with NCA for longest time. And in the entire pedigree of chemistry, you tend to look at NCA as the most toughest one to work with, because it's very volatile. So what we don't, what doesn't get discussed in India is that while everybody is rushing towards making batteries, there are very few groups like Yashodhan and others who worked on creating secondary systems. Like Ather did that, Yashodhan did that, is to create secondary systems around that battery to extract and stabilize that chemistry so that it can perform in India. So I think it's the other engineering talent that has to come together. to unlock the true potential of a chemistry. When you don't have that, then perhaps you start to lean onto other chemistries like LFPs, or maybe like what we look at LTOs. Everything has a different use case. I look at log9 batteries. Log9 batteries can't go in all the vehicles. They are designed for a specific vehicle form
Yeah.
factor, for a specific use case.
Yeah.
And hence, our question should be: what is the vehicle? Which is the company? What's the subsystem that it comes along with it? And I think one very big thing that's coming out from all this discussion all the time is, I'm a big proponent, and I'm working with the government of India onto this, is to standardize the batteries in India through some rating.
Yeah.
When you buy a compressor, it's a 2-star, 3-star compressor. When you buy when you buy an engine, it's a 1500 cc engine, 1400 cc engine. Mileage and everything is a secondary. Then you know what you're getting in. In
Yeah.
batteries, you have no way of knowing.
No,
Everything
no
looks like
way.
lithium-ion batteries. So what is the rubber stamp that a common man can recognize and make that decision when they're purchasing that? Okay, fine. I'm buying a 2-star battery. It's supposed to last that long. I'm buying a 5-star battery. It's supposed to last that long. So on and so forth. So I think we,
The,
as a community, has to do that.
because there is a, you rightly said, there is no star system, unfortunately, and other standardization that government has to implement in terms of the charger. There is no standard charger socket or anything. And other thing is that people always have a perception like, oh, battery packaging is very easy, anyone can do that. So any two people can, oh, I have the electrical mechanical, just build a battery pack, cost effective way. But no, there is a lot of engineering, lot of thermal, chemical, mechanical, electrical, because you are building a safe bomb, which is the source of energy, which gives you from place A to place B on a sustainable way. So battery packaging is not at all easy. If people are thinking, oh, just doing something, no, you have to learn lot many things, and I'm sure everybody will agree. Battery pack making. So that's the thing, I guess.
Yeah, and just to add, like I previously worked extensively with battery packs and all when I worked with Sony before, and yeah, even in terms of design and all, it's okay. But when you go for manufacturing, because
Yeah.
having a good quality control is very important. At least I remember when I was when my design was getting manufactured, the inline there were at least 50 to 60 tests. Those were happening on only BMS PCB when the product was being pushed out of factory. So I don't know what kind of taste people do here, but that is also very important. And one more thing that I heard when I used to work with the OEMs like Yamaha and Honda, they always insisted that we need a secondary protection inside a battery. Like you have microprocessor and AFE, that's okay, but we need some kind of secondary protection. So these type of standards, at just two of you mentioned, there has to be some kind of rubber stamp. Okay, this has 2-star, 3-star. It has a secondary protection. Something of this kind. If there is, it's there. Then it will be. Then customer or OEM can take a cautious decision.
Just to add on that, at the moment, like lead acid battery, what we use in our car, after 4 5 years we replace. To happen this, and we get some money back. Basically, they do recycling, remove the lead and all that. To happen this process from developing of the lead acid thing, it took 15 years time. Lithium ion battery recycling, the companies like Umicore and all done it extensively in Europe. It's very expensive, but people are coming up in various part of the globe, the recycling process, removing the electronic part, mechanical, electrical part, copper, aluminum. Main is the copper, aluminum. If you look at the battery, and then what chemistry you use, so it will come eventually, but cashback offer will take some time. If you thought I will give my electric battery pack from the car after the 6 7 years, and I will get some money, it will take some time, but it will happen eventually. Yeah. There are in BMS you do that actually. If there is a temperature increase, there are isolation monitoring and many other aspects where you have a alert where your contactors will open. The even the BMS development and the safety aspects in the battery pack going towards SLC standard. SLC standard means the airbag safety, which is called functional safety ISO 26262, and but it's a expensive process at the moment, but eventually the norms and it will come where the OEMs will adopt that thing in every EV car or EV vehicle in India is concerned.
How much technology can be adopted from semiconductor chip making machines? These are two different things. I mean, both work at a fab level, but I think the uh, at least in the at the cell level, what you're doing is the technology is more towards. There are 5 or 6 steps. So how do you make slurry? How do you coat the slurry? How do you calendar? How do you cut? How do you fold? What's your cell architecture? How do you fill the electrolyte and seal it? So those are the steps that you have to go to make a typical lithium-ion cell, and it is operating at a much larger level than what a typically a semiconductor works. At semiconductor, is using a lot of laser and other mechanisms to etch certain things on the semiconductors. So the only commonality between the two is that they both these manufacturings are very environment dependent. For example, for us to create these lithium-ion cells, we had to create civil infrastructure rooms that are working at 1% RH. That means 99% dry rooms, very, very expensive, very, very sophisticated equipment, manufacturing setup is required, which is similar to both of them. I mean, when somebody has to enter those rooms, you have to wave the entire, suit. You don't even you're worried about the amount of moisture that comes out when somebody's breathing in those rooms, because that can contaminate your cells. So the level of sophistication in the manufacturing, they both come very close. Really, fab is still slightly higher than that, but they are not interoperative. I think you're asking this directly to me. We are the only one who's manufacturing lithium ion in India. Log9 lithium ion cells are based on a particular chemistry that can give us about 15,000 cycles easily. But that doesn't mean that every lithium ion cell that will get created in India will give you 15,000 cycles. We are using a very uh, hand-picked, sophisticated chemistry that is designed to give you 15,000 cycles. Generally, a lithium-ion cell that you get can give you as low as 500 cycles and maybe as high as 2,500 cycles. That's kind of a ballpark range that you should have in your mind.
Harshad can give in
Yeah,
details.
means there are standards that you have to, when you put any product into the market. This is one of the things that you have to take. Like, because of your product, other things are not getting affected. The radiation or that gets out of your product is not affecting other products. And in the same way, if certain noise from outside comes to your product, the function should not change. So these are standards you can go and easily look it on Google. I think
I think we covered.
this, yeah.
Yeah, it is covered already.
Yeah.
So, with that, I think we have covered up all the questions put up by our audience so far. I can see one more questions. If I can project it, and yeah.
I think typically the errors that can come is there are many levels of errors that can propagate. A simple thing like when let's look at what is happening in the cell. So typically, you are taking a particular metal plate, a foil, and you're coating a certain material, a cathode material, onto it. Uh, and so, if the slurry that you made is not correct, it's not the particle size is the distribution of those particle size is non-uniform, then your coating will be non-uniform. And if you have non-uniform coating, then what you're choosing about it depends on where you cut that cathode material from. You will have cell level variability. The other thing is there's a lot of coating of graphite or carbon that can tends to go on to other side, and if that coating is not proper, then the bulging of the carbon as the lithiation dilithiation starts to happen, that can come in, so that the cell can become extremely unstable when you charge and discharge it because of the coating. So improper coating tends to give you very fast degradation of cathode materials, improper depositions of lithium, and also on the carbon side, if you don't do it, then you get a swelling and uh, what it swells very very fast. The other thing is if the coating is not proper, you tend to get dendrite formation very fast. So that's also one of the things. Another challenge is that if you have contamination in your cell, that's a death sentence, because even if you have certain dust particles, it can have a very fast short. Perforation, if the manufacturer if there's any kind of metal that gets into your separators at the end of the day is a very skinny separator. Any level of compromise over there is a sure short circuit, which can happen very very fast. So I think a lot of problem can come if the standardization of the cell manufacturing is not done. Simple thing, moisture content, even during electrolyte filling, and when you dry that electrolyte, sometimes you can have. So, in my opinion, I think there are many things that can go wrong. But what we typically tend to see is if there has been improper coating, it will lead to shorter cycle life, and if there has been improper coating on the anode side, it will lead to very fast dendrite formations.
No, I can say that. Might be Harshad will answer more. But for example, the cell chemistry is like LFP and all has cell imbalance problem because of their theoretical plateau voltage range over the period of time. So you need a more BMS detailing, I can say, than in NMC. NMC chemistry is comparatively very stable over the period. So might be that's one of the thing, and other safety aspects that you have to add more. Maybe Harshad, you can add more.
Yeah, actually, different cell chemistries, it's difficult to homogenize the BMS
Yeah,
since, say,
yeah,
for example, LFP, it has a very flat curve, and NMC, NCA, it pretty much, there is a slope.
slow.
So, in that case, you need a different resolution for your analog front end to take the cell level voltages. So, if you end up using this LFP for NMC, there could be over design or those type of things will happen, and there is no one fit for all solution. You have to design the any product, it's a battery, vehicle, cell, from completely ground up, bottom up approach. It's not that either say a Legolo, either say a Legolo, it will work together. It's not going to work.
Okay. So with this, I think we have covered up all the questions from our audience signs. So now I would request, where you have interrupted, I have interrupted all of you, like, going with closing remark. So can we start again with Dr. Yashodhan first?
Okay, just a minute. I think yeah. So closing remark is yeah, there is a lot of uh, plus minus. If I want to buy a EV, still a question to everyone, including me. But as a EV battery pack maker, I am promoting everyone like we have to think beyond and start to use EV. I hope we will sooner get more cells from Log9 so that we can use in our vehicles, which is make in India, because country always come first in terms of, and we don't want to miss the bus like semiconductor industry in the EV domain. So I encourage everyone to use EV. Yeah, that's my remark.
Thank you, sir. Pankaj sir, your remark, please.
Yeah, completely seconding Yashodan onto it. Let's all of us get into the EV bandwagon and let's create technologies made in India for India. We're committed to making the cells for India, and we have Harshad and other team members who will take those cells and create the right technology. I think at Log9 we are very focused by only one very simple thing. If it is good for climate, we will do it. And we are all 400 engineers working in this center are all gunning for that. Our true north star is that we should have minimum dependency on any foreign country when it comes to our own growth and development. And with a 50 billion or a 60 billion dollar trade deficit with a neighboring country, it's very this journey of electrification in India, whether it's stationary or EV, the right way to do it is to do it internally, because as long as we are small enough, our dependency, we may be creating technology, but at the same time, we are paying for somebody else's hard work, somebody else's innovation, somebody else's supply chain optimization. Let's spread the money out. We have our GDP depends on a lot in terms of what we can do internally. And the more we are able to create technologies grounds up within this country, whether it's BMS technologies, whether it's cell technology, thermal management technologies, or other EV platforms that are made for India, the more we make in India, the more stronger our country will be. And if, for all the engineers who studied 25 years and the last 3-4 years of engineering, if you don't do it now, there's never a second chance, at least in the next 10 years, to make a big impact. So we all used to ask us, how can I build this country? I think the calling is out there for everyone. Let's use our mind to create what this country needs.
Well said, sir. It's really encouraging. So we'll conclude this discussion with the closing remark from Mr. Bhavesh.
Thank you, Pallam. First of all, I would like to thank our esteemed panelists, Mr. Pankaj, Dr. Yashod, and Mr. Harshad. Had some very interesting and insightful conversation on a lot of different topics. We started with battery chemistry, and then battery systems, and then vehicle integration and charging infrastructure, and so on. Basically, looking at the supply chain aspects that we have today, and some really great closing remarks from all of you as well. So I would like to thank eMobility Plus as well for arranging this panel discussion. We had some great questions as well. I think we had some really insightful questions there, and we were able to spend some time in looking at that. I think it made us think too, in terms of what needs to be done. So thank you very much, and wish you all a great day.
Thank you. Thank you very much to all of our esteemed panelists for this wonderful session. And a very special thanks to Mr. Bhavesh for superbly conducting the discussions, tapping all aspects of, the EV battery value chain. So with this, we come to the end of this virtual event. Thank you, everyone, for sparing your precious time and encouraging support for this event. And we can promise to come back with more exciting topics very soon. It's time to sign off. Have a wonderful weekend.
Thank you.
Thank
Thank
you.
you all.
Thanks, everyone.
Have a nice day.
Bye.